don't have one.
Give me a second, okay? Put this. All right, so today is Thursday. Pull this one out. Today is Thursday, the 7th. We are going to work on the warm-up. We're going to make sure that we finish our notes from the previous day. Make sure we finish those notes. We have some intro to geometry stuff that we need to do, vocabulary. And then I want you to do some independent practice on inequalities, solving inequalities. And that's it's gonna be, the link is on my Canvas page. You need to make sure that you show your work. We're gonna put this in our interactive notebook. Okay, the work we're gonna put in our interactive notebook. All right, the homework for tonight is going to be Thursday problems in the packet. And we labeled the problems. We did label those. Thursday problems in the packet. I need you now to work on your warm-up. All right, so let's go over the warm-up. Okay, so here, all we're doing in this one is we're solving this. So here we're going to subtract. We got 13 over 8. We can type this in our calculator. I'm going to show you how to do that. Look. Type in 2 minus. Let's type in the fraction. Parentheses is right above the 8. Now the fraction we're going to type in is 13 over 8. So type in 13. Use the division sign for fraction. 8. Close the parentheses. The parentheses is right above the 9. The closed parentheses. Hold it up so I can make sure that you type that in correctly. Press enter and write that answer down. Press enter and write that answer down. Okay. Press enter and put your phone up, baby. Press enter and write the answer down. Very good. Write it down. Press enter and write the answer down. Press enter and write the answer down. Yes. Oh, no. Is there not one in the So he gave it to you. Okay. No. Press enter and write that answer down. Yes.
How do I put the little whatever that is?
You have to tell me what you mean.
Yeah.
Or the divide.
That's divide.
Oh, my bad.
That's okay, babe. All right, let's look at the next one. Number 2. Second problem. It says the product. What does product mean? Yes. Multiplication. We do that all the time, girl. Product is multiplication. So we're multiplying. It says the product of. We got 6, so we're multiplying 6. And this is the other number that we're multiplying together. A number, so that's x or n. We can use n because we don't know what it is. Increased by 3. So we have the product. So we have 6 times n plus 3. Okay? Then they say is. Is equal to. It's the same as 15 less than. So that means we're going to subtract 15 from something. We're going to subtract 15 from 12 times the same number. So 12n. So we got 12n minus that 15. Okay? That's the equation that they want you to solve. All right, so first step to solving an equation. What's the very first thing that you need to do? Come on, yes. Do distributive property. Distributive property is first. 6 times the both numbers in the parentheses. 6 times n is 6n. Then you're going to do 6 times 3. That's a positive 3 because it's a plus sign in front of it. What's 6 is 18. Positive 18. Bring this side down, okay? Now what are we going to do? What's the next? I forgot to put 12 in. It's supposed to be 12 in. It says times, yeah, 12. All right, so now what do we do in this problem? Combine like terms. So can I combine this over here?
Yes.
No, I can't. These terms are not alike. 6n and 18 are not like terms. Can I combine 12n minus 15? They're not alike. Okay, so I skipped that step. What's the next thing that I need to do? Yes. Not yet. Almost though. Move the variable to the same side. I'm gonna move the smaller one. Which one is smaller between 6? How do you move? You want to move all of this over here. How do you move a positive 6? The whole thing. Not detach it, but move it. Yes. Subtract it. So you have 6n minus 6n. This is going to give you 18. It's equal to, and what's 12n minus 6n? 6n. Bring down the minus 15. Okay. Now, Tater, I am going to isolate the variable, right? Yeah. So what do I move first when I'm isolating the variable? 15. The 15. Get rid of anything that you can add or subtract first. This is a minus 15. What's the opposite of that? Addition. So you're going to add 15 to both sides. What's 18 plus 15? 33. Count. What's 8 plus 5? 33. Now what am I going to do to get n by itself? Division. So divide both sides by what number? 6. Let's type this in. What is 33 divided by 6? 5.5. Somebody said it. 5.5. 5.5. Good job. Okay. Yes, baby. We typed it in the calculator. Type this in the calculator. Huh? Well, you got to get a calculator. Type it in. Okay. Anybody else? All right. Good deal. Okay. Thursday's homework. This is what it looks like. Let's make sure we know how to do Thursday. Did you need me to go back? Did you need me to go back? You said yes? Okay. I couldn't hear you, baby. I'll pause. You got to speak up, okay? The only way I knew is I kind of looked at your face. But tell me when you don't have it. Yes, baby. Okay, again, to make a fraction in the calculator, I'm typing in this. I type it in as 2. Then I type the minus. And then you see right here, parentheses. I'm going to put my fraction in parentheses. Parentheses is right here above the 8. And then I type in 13 divided by, fraction is division, 8. And the close the parentheses is above the 9. Got it? Kylie, did you get it? Did you understand how to type it in? Okay. Did you finish, babe? Okay. All right, let's look at the homework. Make sure we understand. Thank you. You have to type it in calculator. Okay?
3.25?
No, it's not. You have to type. I told you how to type it in the calculator.
No, I did. I was just saying.
You did something wrong. Yeah, you had to have done something wrong. It's not 3 point. It's just a decimal. Point blah blah blah. It's not 3 point nothing. Okay. It's not. You have to type it in. I'm not gonna do it for you. I showed you how to type it in. All you gotta do is press enter. Come on, y'all. Stop being lazy, please. Yeah, we are because I showed you how to do it twice. If you have a question, then just say, can you show me how to do it? But don't just try to bum answers off people. All right, look at this. To get G by itself, you have to get rid of this positive 8. What's the opposite of adding 8? Subtracting 8. Good job. So this is gone, and I'm left with the G. What inequality is this right here? Greater than. That's great. You're right. You're right. Greater than. You said it right the first time. And then here, what is 6 minus 8? Type it in if you don't remember. -2. So we're going to put a circle above -2. It's going to be an open circle because there's no equal to. And we're going to shade. Go ahead. Say again, baby. I didn't hear you. What she say? You're not going to shade it. Because it's no equal to. Right. There's no equal to sign here. No equal sign. So no shade. Now, all the numbers, this is less than. So that means it's smaller. This is less than. So the values that are smaller are to the left. This is smaller. Values that are smaller. Going to the left.
It's super important today, like this week. If you do not know how she is combining terms to solve for G, here is super important that you get with me or Miss Reyes to get that.
G is greater than -2. Why are we going to?
Oh, greater. Thank you. I said less than and then greater. I said less than is greater than. Thank you. Thank you, Tater. All right, so if we're going greater than, then it's going to be bigger. It's going to the right. Mm-hmm. All right, let's do number 2. How do you get A by itself there? Yes. Say again, baby. I couldn't hear. Add 3. Great job. So when you add 3 to both sides, this is gone and we're left with A. What inequality is this? This is less than or equal to. This is equal to. So that means you're going to shade in the circle. It's going to be a closed circle. What is 1 plus 3? 4. So now we're going to put our circle above positive 4. We're going to shade in the circle because it's equal to. Now, since it's less than, that means it's smaller than. Which numbers are smaller than? Do we go to the left or to the right? To the left. This is smaller. Any questions about this? What's baby? Guess that. Okay. We add 3 because we got to get A by itself, right? What's on the same side as A? A minus 3. The only way to move a minus 3 is to do the opposite of that, which is to add. Do you understand that part? Are you okay with it? Okay. Because it's already a 1 over there. So when you add 3 to the 1 that's already there, you get 4.
If you add 3 to the left-hand side of the inequality, then you have to add 3 to the right-hand side of the inequality line.
Whatever you do to one side, you automatically have to do it to the other side.
And that's how you move it. Otherwise, you're just subtracting it from one side and making it off balance.
Are you processing it? Are you all right with it? Okay. Let's just do this one more, okay? This is you see this right here? We got negative 20 plus m. We got to get m by itself. So that means we have to get rid of the negative 20. What's the opposite of that? How we get rid of that? We have to add 20 to both sides. Are you okay with that? Is that okay? That you're adding 20 because this is a negative 20? Okay.
You're taking it off of one side and adding it to the other. So then you take that negative 20 and add 20.
And what does that give you?
0. So then you're adding it to the other side.
Just like Ms. Moore said, this is going to be 0 now. And you're left with just the m over here, okay? Bring down the inequality. What inequality is this?
No.
You said greater than or equal to. Okay, so that means it's going to be a closed circle because it's equal to, okay? You're going to close the circle up, shade in the circle because it's equal. There's an equal to sign. What's negative 20 plus, negative 24 plus 20?
Negative 4.
Negative 4. So that means that you're going to find negative 4 on the number line and put a circle and shade that circle in because it's equal to. Very good. Then you're going to shade to the right because these numbers are bigger than. These are your greater. Okay? Any questions about that? All right. Go ahead. Put this in your folder. Make sure you finish the rest for homework. Take out your interactive notebook. We put inequalities on this page right here. We worked on worksheet yesterday on inequalities. Please take that out your folder. And we need to make some corrections because I don't know what I was thinking yesterday. All right, so let's look at the first one. This one's not right, so we need to do this one again. Do I have an eraser? Okay, thank you.
Miss Reyes, what math is this?
This is third period.
No, I'm saying like, is this like math, stuff like that?
It's regular 8th grade math.
Someone told me you taught math 1.
I do.
They showed me the homework, and I was like,
That's a different class.
That's a different class. That's a high
Yeah,
school class.
my friend was like, can you help me with the math homework? And he said he's in math one.
He's in my math 1 class.
Yes, I know too.
Yeah, that's high school math.
Yeah, he said, told me, I was like, bro, what?
Yeah, it's completely different. All right, erase that one because Miss Reyes was not thinking she did that one completely wrong.
Wait, what's
Yeah, we shaded it wrong. All right, this right here is greater than. I'm surprised y'all didn't say anything.
Can I get this?
You didn't get this from yesterday? I thought you were here. Here, baby. All right. So here, this is greater than. There's no equal to sign. So the circle is going to be open. Okay, this is going to be an open circle. Okay, look at this. Greater than. Put the circle above 2. Do not shade it in because it's not equal. And greater than, that means you shade to the what? Right. All the values that are greater than. Okay, so now let's look at this. We need to choose one of these numbers that are here in this shaded region. We need to choose one of these. Doesn't matter which one we choose. We could choose number 3, 4, 5, 6, 7, 8, as long as it's greater than 2. What number would you like to use to check this equation? As long as it's greater, you said what? 4. So we got 3 times 4 plus 5 greater than 11. Okay? So go ahead. 3 what? Times what?
4.
Which is what? 12. Then we add what to it? 5. And what does that give you?
17.
This is 17. Is 17, this is greater than, is 17 greater than 11? Yes. So then this, what we did is correct. Okay, and everything else, that was fine. That was just the only one that we did that was not right. Okay. All right, so let's look at the last one that we did. Let me pause to make sure you have this. All right, let's look at the ones that are on the bottom. This is less than, just less than, so it's going to be an open circle. So we did this already. So now we're just checking. As long as we choose a value that's less than 5. What value do you want to choose to check it? Any number that's less than 5. Give me a number less than 5. 3, okay? So let's choose 3. We got 4 times 3 minus 12. This is less than 8, okay? What's 4 times 3?
12.
We got 12 here. Then we got minus 12.
Minus 12.
What's 12 minus 12?
0.
Is 0 less than 8?
Yes.
Yes. So that means that what we did is correct. Okay. Yes, baby? Mm-hmm. Letter F. Anybody still writing? I want to move on if you're still. Okay.
Me?
You are? Okay. Let me know when you're finished. I'm going to pause. Okay. Let's look at F. All right. The operation that's between a number and a variable is multiplication. Okay. This is multiplication right here. What's the opposite of multiplication? So the only way to detach this number that's attached to that's attached by multiplication is to divide it on both sides. So we're dividing a negative 0.5 on both sides. That's the only way to solve a problem that's like this. When I divide a negative divided by a negative, that's going to make this a positive 1x. Or just x, okay? When you divide both sides by a negative, the inequality here is going to flip. Anytime you divide by a negative or multiply both sides by a negative number, you flip the inequality. So now instead of it being greater than, this is less than. Let's type this in the calculator. 4 divided by negative 0.5. 4 divided by negative is right here. Negative 0.5. And what do you get as your answer? A negative 8. Oh, how do you do the negative? I'll do it one more time, okay? You did 4 divided by, negative is down here. Negative, then we got point what? 5. Do you see it now? You okay, baby? Okay. We in COVID. All right, here we go. This is less than. So this is going to be an open circle because there's no equal to, okay? So let's put negative 8 here in the middle and put some values on this side that are greater than. That's going to be negative 7, negative 6, negative 5. Numbers that are smaller than, that's going to be negative 9, negative 10, and negative 11. Put a circle above negative 8. What numbers are smaller than? Is that going to the left or is that going to the right? That's the, say again, I can't tell. I got one person said left, one person said right. Which one y'all think it is now? What's smaller than? Less than? It's left.
So if you owe $7 to someone, is that more than 8?
It's negatives. Yeah, negatives. They are. This is less than. Okay, so we got to choose a number less than negative 8 to substitute for x. What number is less than a negative 8? Yes, negative 10. So let's choose negative 10 here. Negative 0.5 times negative 10. Bring down this is greater than 4. So let's multiply this together. Okay, look. We kind of know this. What's half of 10? 5. What's a negative times a negative? A positive. This is positive 5. Is positive 5 greater than 4? Yes. Yes, it is. This is true. So what we have is correct. All right, I want you to do G and H on your own. Give you a couple minutes. And I want you to paste it in this notebook. Okay, we're going to place this in this notebook. And this is going to be inequalities practice problems. Page 26, inequalities practice problems. And I'll pause, give you time. Make sure that you paste it down on page 26. Yes, sir.
I'm gonna blow my nose in the bathroom.
No, not in the bathroom, but right outside the door. Yes, baby. Yes. You would have to be after Kylie, though. Okay. The next page is page 27. It's geometry vocabulary.
Geometry.
One. No, it's math.
Oh, it sounds like science.
Maybe so.
Don't it sound like science?
I don't know. Maybe so. 27. This is page 27. And this is geometry vocab. And it's going to take up 2 pages because it's just a lot of vocab, but we're filling in the blanks. It's not going to take us long to do this. Okay. Geometry vocabulary. Okay, at the top, look at this. It says similar. The definition for similar is same shape, but not same size. So not same goes in the blank. Not same size. So you might have a small right triangle and you have a larger right triangle. They are similar, but they're not the same. They are the same right triangle. One's bigger than the other. Yes. Congruent is the same shape and same size. Same shape and same size. Congruent. The formula for similar is not formula. The symbol looks like this, like a little squiggly line. The symbol for congruent is this. That's the congruent symbol. Congruent means that it's the same shape and size. This is the congruent symbol. This is the symbol for similar.
Looks like water.
Okay. All right. So if you have a square and they're twins, they're exactly the same shape and size, they are congruent. You might have a triangle, they're twins, they're exactly the same shape and size, they are congruent. That's what congruent means. Line continues without end in opposite directions. A line by definition never ends. So it looks like this. It has arrows at the end. They might name this line because they might have points. They might name this line AB. So you could see the name of this line, AB, and right above it, this is how they name that line. A line segment. No, you've already been. A line segment is blank of a line. It has two endpoints. It's a part of a line and has two endpoints. So it's a part of a line. It's a fraction of a line. So it has two stopping places. It doesn't have arrows at the end. This could be C. This could be D. So you name it. It will look like this. You could name it CD or DC. And it doesn't have arrows on the end. It just looks just like that. Okay? Just like this one could be BA. This one could be DC. Okay? Array has one endpoint, and continues without end in the opposite direction. Continues. Array has one endpoint and it continues without end in the opposite direction. This is continues. So array looks like this. You have one endpoint, and on the other side, it continues without end in the opposite direction. This could be NP. Okay? This is ray NP. So when you name the ray, you have N and P. Just make sure that the arrow is pointing in the right direction. The arrow is where P is. If you reverse the order and put P in, the arrow still needs to be where P is. Okay? Angle, please put your book away, babe. Angle has two rays, so it's two rays that share the same endpoint. So this is what an angle looks like. It has two rays. You have a ray going this way, and you have a ray that's right connected with it going this way. An angle is made up of two rays. You see these rays? It's two rays that share the same endpoint. Both of these rays share that same endpoint. This could be A, B, C. What is the name of this? The name could vary. We use the symbol for angle that's like this, has a flat line here. You could say A, B, C, A, B, C, or you can say angle C, B, A, C, B, A, or you can just say angle B because B is right here in the center.
I'm gonna take over Miss Rice. Feel like you need a break.
No, I've had a headache for 2 days. It's all good. We're good. It's probably just sinuses. Vertex, the point in which two rays meet. The point in which those two rays meet. Okay, so your vertex of your angle, this right here, this point right here is called the vertex. This point right here, the point where those two rays meet, that's called the vertex. This little point. The point where two rays meet is called the vertex. That's okay. Complementary. Complementary is two angles whose sum measures 90 degrees. It's when you add the angles together and it equals exactly 90 degrees. It's complementary. So you could have two angles. One of them could be 50 degrees. If the other one's 50 degrees, then what would the other one have to be in order to be 90? 40 degrees. Both combined, both angles, when you add them together, is equal to 90. It's too late now. Supplementary. Supplementary are angles, okay, are two angles whose sum, when you add them together, the two angles add up to 180 degrees. That's supplementary. Two angles whose sum add up to 180 degrees. So we have a straight line, which is 180 degrees. This first angle could be, let's say this first angle is 40 degrees. If this angle is 40 degrees, then what would this other angle have to be in order for it to be 180 degrees, both combined? Come on, what would this other one be? No. 140. 140 plus 40 is equal to 180. These two angles combined equal to 180 degrees. This angle plus this angle is 180 degrees. They are supplemented. Bless your little pointy head. Vertical angles. Vertical angles are angles that are diagonal from each other. And they are congruent. That means they have the same measure. You okay? So we have, let me show you what vertical angles look like. Let's draw like a cross or two angles that intersect. This is angle A, B, C, and D. Let's pick out the vertical angles. The angle that's vertical of angle A is C. Angle A and C are vertical. That means if A is 80 degrees, then C is also 80 degrees. They both have the same angle measurement. So angle A is congruent to angle C. They are vertical. So if this is 80 degrees, this is also 80 degrees. What else is vertical in the picture? Somebody said it. Nope. What else is vertical in the picture? If A and C are vertical, yes. D and B are vertical. That means D and B have the same measure. So that means if B is 100 degrees, then D is also 100 degrees. They are vertical. Skew lines. Skew. That sounds funny, don't it? Skew lines are lines that are on different. They're on different planes, and they never cross each other. They never intersect. What does that look like, Miss Reyes? Okay, so we have a flat surface here, and it has a line. Do you see that? And on it, and then we have another flat surface that has another line. Now, if they were in the same flat surface, they would cross each other. But because they're in two different flat surfaces, they are never going to cross each other. Just like, and I'll show you with this, demonstrate with these two pieces of paper, okay? What you say, girl? What you say, girl?
I'm spelling the word wrong.
Girl. All right, girl. All right, this is a line right here that's going up and down, and this is a line that's going like across. If they were in the same flat surface, they would cross each other. But because they're in two different flat surfaces, two different planes, they are never going to cross each other. So they are skew. Okay? These lines are never going to cross because they're not in the same flat surface. That makes these lines skew. Okay? Any questions about that? You get it? Parallel lines. Not all at one time. Just do a little bit at a time. It'll come back. It'll come to you. Parallel lines. Lines that are in the same, that are on the same plane. And never cross. So these lines are in the same flat surface, but they're going in the same direction, so they never cross each other. Like these two lines, they're never going to cross because they're going in the same direction. These two lines right here, they're never going to cross because they're going in the exact same direction. So they are in the same flat surface, but they never cross each other. Those are parallel. Intersecting lines. Intersecting lines are lines that cross each other. Lines that cross each other, okay? So that all they do is just two lines that cross each other. If they cross each other, they're intersecting. Okay. Perpendicular lines, help us, Lord. Lines that cross each other, y'all crazy, to form 4 right angles. So if you have like a cross, lines that look like a cross, they're called perpendicular because each of these angles that are formed are going to be exactly 90 degrees. Form, F-O-R-M, okay? Yeah, it's form, sorry. It looks like it's not a right angle, but it is. This is 90 here, 90 here, 90 here. So just be careful. It has a box in the corner, then you know it's a 90-degree angle. Adjacent, my room is adjacent to Mrs. Savage's room. My room is also adjacent to Mr. Havestad's room. So adjacent is side by side. Angles that are side by side. So these angles, I have angle, this is angle A and angle B, they are adjacent. That means they're side by side. These angles here, CD, they are adjacent. They are side by side. The last one we're going to do today is corresponding angles. Corresponding angles are angles that are in similar positions, okay, and are congruent. That means they have the same measure. So you might have and you have angle A, B, C, D, E, F, G, and H. The angles that are in similar position with A is E because they're both in the top left corner. So angle A is congruent to angle E. They're both in the top left corner, top left corner. What angle matches up with B? What angle matches up with B? If A and E match up, yes. F. Very good. B and F. Good job, baby. B and F are the same measure. What matches up with C? G. C and G. They have the same measure. What matches up with D? H. Good job, y'all. Oops. What are you at? Yeah. No. Own language. No. All right, so we're gonna paste this down on this page right here. Okay, DJ. I'm gonna give you one-on-one help with how to paste this down. Okay, so all we're doing when we paste it, we fold it just like this, baby. And we're gonna put glue just on the back side. We're gonna put glue on the back side and just glue it down just like this. So that when you glue it down, you can just open it up like this.
I think y'all got two, right?
You have just one glue stick.
Oh,
You should have 2 sheets. I need that. We're doing the other one tomorrow. Put the other one in your folder. It's mine. You can use it, but let me glue this down first. I'm supposed to get it whenever I want it. It's mine. Here.
nuts.
Is it? Did I stop my video? Yeah, I did. No, I didn't.
I got it.
No.
No, please don't, because they're gonna be like, what the world?
Yeah, it didn't. Glasses, it wasn't.